If you happen to be a researcher dabbling around with 3D geometry, you've probably heard of MeshLab. And if you also happen to be a software developer, this video is just for you. I will show you how to set up the entire solution, debug MeshLab, and I will also attempt to implement a custom mesh processing filter. Stay tuned.
3 days later.
Okay, I am officially giving up. I have tried, well, pretty much everything that was in my power. The changes aren't applied unless you go here and you apply a transformation. And all you really need to do is just preview this and the changes will be visible. What's up, guys? Welcome to my video series, actually the very first video of my video series called Understanding Open Source Codebases. Today we are going to take a look at MeshLab, which is an open source, portable and extensible system for viewing and processing unstructured meshes. It is supported on Windows, macOS and Linux. It was developed by the Visual Computing Lab of the Institute of Information Science and Technologies, ISTI in Pisa, Italy. And it is used in various academic and research contexts, ranging from microbiology, cultural heritage, paleontology, orthopedic surgery, orthodontics, as well as the obvious geometry-related applications such as surface reconstruction. According to the official repo, the latest stable release is from March 2022, making it the 25th release since 2016. And one important thing to note is that you need to clone the repository recursively, because otherwise you will be missing an important piece, which is the VCG library. So the VCG library is a geometric library that covers the inner workings of the mesh implementation and other stuff. It can be found on the GitHub authors list of pinned repositories. It's here, VCG lib, right? So it can also be used as an external third-party library for other projects that don't necessarily want to use MeshLab with all of its components and all of its UI. After recursively cloning the repository, we will create an out-of-source build using CMake. I decided to use Visual Studio 2019 for this because I will be needing some extensions that I consider useful for this video. Now, after trying to build MeshLab as a whole solution in debug mode, I am missing some files from the Eigen library. An important thing to note here is that MeshLab uses a special flag for whether you want to use the system installed Eigen library as a dependency for the VCG library. If you have this flag turned on, it may well result in build errors, as it did in my case. And the reason for that was because the Eigen 3 include directory was set to a custom made directory because I was tinkering around with some of the CMake variables. Unfortunately, I couldn't find the reason why it was changed in the first place, but the problem was solved after turning allowed system Eigen off and sticking to the bundled Eigen as a VCG dependency. It will take some time for the debug symbols to be loaded. You also need to make sure that you set the MeshLab project as a startup project. Now we can notice that MeshLab uses Qt for the UI components. So this thing is a Qt application. Now, what this means is that you do need to have Qt installed. In my case, it's Qt 5.15.2, and you need to have Qt installation directory in the path variable as an environment variable, and also you do need to have, I think you do need to have this Qt directory set to the MSVC 2019_64. So that's the Visual Studio compiler for Microsoft 64-bit. Alright, so what we want to do right now is test how readable and how easy to debug MeshLab actually is. And what we're going to do is what I will call from now on the breakpoint test. The breakpoint test involves picking some random features that I haven't used before because, I was already playing around with MeshLab before. So now I'm going to choose different functionalities, different features from those that I used or debugged before, and I'm going to set a timer and see how fast I can find the actual functionality, the actual implementation, or the actual function that I'm looking for. So the very first feature we are going to test is called Laplacian smoothing. So that's an explicit sort of mesh smoothing using the Laplace operator. The following feature we are going to look for is Loop Subdivision, which subdivides each face into 4 subfaces. And then the last one is per face in radius over circumradius quality metric. Alright, so there's a little disclaimer. Unfortunately, debugging all the features that I previously mentioned wasn't so straightforward. So let me show you what I had to do to actually make it work. Alright, so if you try to import a mesh in the current situation, in the current MeshLab build, you will have the following error. And this is caused by the fact that the plugins aren't actually loaded. So if you actually look for the source of the error, it is caused by this particular value to be false, right? So if the plugin manager returns a false to the OBJ plugin, it triggers this warning. Now, why are the plugins not loaded? Let's take a look at what the plugins actually look like. So here in the MeshLab build we have all the plugins as DLLs. So normally they are installed as DLLs in the correct binary directory, but in this particular configuration in the out of source build, they are in the configuration folder, so debug or release. Now the thing is that if MeshLab tries to look for the correct file, right? So this is the plugins directory. There's a function above this in the call stack which actually goes one level up in the directory. So this is the path for the plugins, right? And you still need to go underneath one level to debug or release. So if you actually want to solve this problem, you do need to put this in. So this is a little hack that will solve this issue. I don't know why this was here in the first place. I trusted the current configuration, the current version on GitHub to be actually working, but it doesn't. So there's a little hack for this if you encountering the same problem. I don't know the exact reason why the problem occurs in the first place, but it probably results from some changes in the CMake configuration, right? It wasn't properly tested or something. Well, it's getting kind of dark already, but I just also wanted to mention that you might also be missing the mesh filter booleans plugin. And the reason for that probably is the fact that some of the external dependencies like CGAL aren't correctly loaded. We are not going to use this plugin, so we should move on. So I will use a Google stopwatch, which should probably work. And I will start from the very first feature, which is Laplacian Smooth. So 3, 2, 1, go. All right, I'll just search Laplacian and see where that leads me. Build uniform Laplacian, vertex normal Laplacian, Laplacian Smooth, filter try optimize near Laplacian Smooth. There's a lot of Laplacians. I mean, it does make sense that there's multiple uses for the Laplace operator on a mesh, but okay, so I might have found something. Okay, let's do that. Let's place a breakpoint here, and let's place a breakpoint here in filter unsharp apply filter. So let's import the mesh that I wanted to import, bunny mesh, right? And let's go to filters. Oh my god, where was that thing again? Oh, Laplacian Smooth. There you go. Yes, we are there. Yes, so this is the ID of the filter that we are using. FB underscore Laplacian Smooth. And yeah, it shows the dialog. But right now, I do wanna, I do kind of wanna see where this ends up when I click apply. So it's been 9 minutes and I'm still looking for the curvature flow. Oh, look. I just clicked on the preview and here I go to the apply filter. So I guessed correctly that I am going to apply a filter for filter unsharp, for a filter unsharp instance. So here it filters the FB underscore Laplacian Smooth. It, I guess it gets the parameters. This is the mesh instance. Well, maybe if I go in mesh type, there's already, so the mesh isn't empty. It has 152 vertices, which is, I guess, the exact number of vertices contained in this particular mesh. So here we have the evaluation for the Laplacian, and it does 3 steps of Laplacian smoothing. So there's some, I guess, special weights for the Laplacian, but there's no input for that. And then I guess just goes vertex by vertex, and I'll just run to the cursor. The mesh has been edited, I guess, and so I think I've already went through most of the thing. These are just the particularities of the Laplacian smoothing as they are applied to the mesh itself, right? So if I just go out, there's some logging, and this is the result. So the dialog remains open, and that's it. Alright, we are back for the next feature, which is the loop subdivision. I'm going to start the timer about right now. And yeah, let's just look for the loop keyword. Loop. And see where that goes. Yeah, there's a whole bunch of things called loops, so let's just do that. Let's just search for the keyword subdiv and filter plugin subdivision. Yeah, it should probably be apply filter, wherever that is. Filters, subdivision, loop, apply. Ah! I missed the breakpoint. So I didn't catch it. Let's go again. Subdivision, subdivision, subdivision modifier. Max subdivision depth. Nope. There's too many keywords for that. Let's loop subdiv. Let's try that. Huh. No results. Loop. Let's go to loop again. Oh, okay. Allow to compute classical loop subdivision surface with the same code. That doesn't look very good. So what are we searching for exactly? Loop sub. It's just a single comment that has this string and a bunch of loop comments. a whole bunch of things that are called loop for some reason. But this is almost definitely connected to loop subdivision in some way. So let's put a breakpoint everywhere in here, and let's go to the filters, subdivision, surfaces, loop, apply. Oh, we have hit the breakpoint. That's wonderful. Okay. Mesh filter, apply. FB underscore loop underscore SS. Ooh, so there's this function, this template function that gets called, but I can't get inside here for some reason. Refine, odd, even. Let's go here. Even flag. Smoothing. Okay, apply. Okay, here we are. Refine, odd, even. So, here we are in a template method that has like 3 parameters, and the first one is mesh type, the other one is some odd vertex class, and then there's even vertex class, and then there's some kind of predicate for edges. So from what I see right here is something that applies a subdivision scheme for even and odd vertices for any mesh type, and here it processes normals. Let's run the cursor here. I guess it goes triangle by triangle, interpolates colors, and then it flags vertices for some additional adjustment, I guess. Well, I don't think I understand this thing very well because it's very difficult to read, and it's obviously supposed to be iterating across faces and applying a certain subdivision scheme which is parametrized by the template parameter. So it works with attributes, even and odd valence attributes, and some kind of edge predicate. Alright, so let's do the face quality function, which is the next feature we want to test. Let's start the timer. Start. Let's go to filters, smoothing, now quality, per face quality function, in radius over circumradius, apply. That's not it, because we haven't hit the apply filter function. So let's do that again. Let's search for the keyword quality. Well, there's a lot of things called quality. Quality mapper factory. Oh my goodness. Look at this quality mapper plugin. This looks like something that could be start edit. Let's go here. And then also let's try stat. Compute per face quality min max. Ooh, okay. That seems like something that could be useful. Let's drop a breakpoint in here, because that will be something that will color each face according to the quality function, which is something that we want to see. I think we have enough breakpoints to actually capture this thing, so let's try and call it per face quality according to triangle shape, in radius, circumradius. Oh no, we missed again. Well, this will be tough. Face quality. Face quality histogram, apply. Let's search for the particular function, which is inRadius. Oh, that kind of narrows it down. Bitquad support triangle 3. Oh, compute a quality measure of the triangle composed by points. And let's do that again. We already opened up the function, so we're good. And now let's apply this. So where are we? Let's go to the call stack and apply filter. This is a color processing filter, and the particular one is triangle quality, inRadius, circumradius. So here it goes face by face, and it applies this particular function where I have already put the breakpoint. So I have found it, I guess. Now, after performing the breakpoint test, we can try and add a feature which will modify the opened mesh, and we will add this as a filter among the deformation filters. So yeah, I'm not debugging right now. I just want to look for the filters menu here, and I want to put an option in here, and the function that I want to implement is called spherify. So it will actually inflate this mesh with a parameter, and the function already exists here. It's implemented in one of my previous projects, so I will recycle this. Yeah, maybe I will need a special dialog for that. I'm not sure. So I will time everything that I need to time and see where that goes. So let's start right now. Okay, so this is called smoothing, fairing, and the deformation. Let's search for the exact string. Match case. Now match the whole word. Okay, here's the filter menu. Filter menu smoothing. Map filter plugins. Yeah. Let's debug that and see where that leads. $266 different plugins. There's 266 plugins and 70 DLLs. Let's look for one of the plugins. Laplacian Smooth. Filter unsharp. Maybe I won't have to create a separate filter for that. Okay, let's add another enum here. FP verify. Let's call it that. Deform spherify. So let's create a label for this. Are there any errors? No? Okay. So I suppose that by adding this, I will just create an item in the filter menu for smoothing, and let's try and see what that does. So there's a whole bunch of plugins that are contained in the filter unsharp plugin, and I suppose I can hide my implementation in there. Smoothing, fairing, and deformation. Yeah, it's not there. Type list. It's not in the type list. Here's where the implementation should be hidden. So let's scroll all the way down here. Let's create another case for this. Something changed. I am missing the Tobin smoothing. Okay, that's strange. This is strange. Where's the Tobin thing? Tobin smoothing. Let's open up the installed version. So after I added the new filter, a whole bunch of things just disappeared from the list of filters that are available under this menu item. So we have Tobin Smooth here, but if you take a look here on the debugged versions, smoothing, fairing, and deformation, there's only like half of these things. So this is not good. I'm assuming there's some kind of map that adds all the filters that should be there. But what should I do if I want to add a new filter? Oh man, that is something interesting. I wonder how it gets categorized into different menus. Right, so here it maps these different plugins. Let's see if it finds the identifier. So it's empty, and if I run it to the cursor, there's 266. It's the same number as before, so there's no additional plugin. MeshLab plugin logger. Filter class. Here's an important thing to note. The filter class is defined here. And let's try and put the filter class in here. Maybe that will help. Yeah, I wonder what that will do. Let's see. Oh look, I changed something. I have no clue what this is. Get requirements. Ah, so it has to be there, even if it doesn't do anything. Requirements. Oh good lord, come on. What is going on? Get requirements. Yeah, it's the exact identifier. 22. The Tobin Smooth doesn't have any requirements. Do I have to move this up? Let's just move this up a little bit. Let's see. Okay. We have one more filter plugin. So that's a success. I was able to create a filter. But there's some issue. There's no filter info, so this is a necessary thing. So I do need to have filter info. Also, let's try and see whether that creates an item here. Yeah, it is there. Wonderful. Awesome. So I need filter info. So this will just be a simple description. Let's just save the time. Now I need to find the proper location for the implementation here. Okay, I suppose this is the place for the implementation. It should probably look very similar to Laplacian smoothing variant of some kind. Vertex. Yeah, so it should accept a parameter, which will just be a default value of some kind. I don't need to make it too complicated. Yeah, so this works, but it requires a template argument list. Okay, C mesh. Oh. I do need to have some knowledge about how to compute the bounding box, then get the center, and then there's going to be a for loop for the vertices. Well, I guess this is the way to do that for vertices, so let me copy this for loop. I do need to define the vertex set somehow. Okay, so I need this. Let me split this, because I can't really see what I'm doing here. So I guess this is actually the correct way to do this. if I'm just using mesh vertex iterator. So I don't have any errors. This is the correct way to iterate through the vertex set. Alright, now I have absolutely no clue how I can actually obtain a bounding box for the vertices. I just hope I won't have to iterate this. Let me search for the bounding box. This looks like something I can use. Box 3M TRBB. Does that work? How does that work? Well, okay, let's do that. And I also need radius. Is this it? Diagonal? Yeah, that's it. So, I got the radius, I got the center. I do want to find out how the individual vertices are actually defined as chord types. I guess that's it. Okay, so chord type. So this is how you extract the position from the vertex, and then you have the same for the normal. How do I get the normal? Norm. Can you get the vertex normal from this? Oh, exactly like this. Cn, I guess this is it. Cn, and it returns a chord type. I need the target normal, which is, yeah. So this is the helper vector, which is just the vertex copied. This is going to be minus center, but I do need to normalize this. Is this how it works? No, this is the scalar. So this computes the length. So let's go back, and I do need to use normalize as a function. So this should return a vector. Now I need to radius times target normal plus center. And now I need to linearly interpolate the vertex and the normal. How do you linearly interpolate? I don't think they're using any internal function for interpolation. Interpolate position, what is that? That's barocentric interpolation. I need a simple linear interpolation. Yeah, I don't think it exists, so let me just stupidly do this. So I hope this is correct. Yeah, I might actually reverse the interpolation parameter, because if the parameter is 1, it should be a complete sphere, so it should go to the target vertex. And I also need to normalize. The last step in this computation is to actually set the correct vertices and normals. So EI, I hope this works. EIM. Yeah, I mean it should return a reference to position and the normal, so I can actually use the equals operator for assigning the value. Okay, let's hope for the best. I guess since I'm building my changes in the VCG library, it just has to propagate to all the projects. So that's why it takes so long. So I guess it computed everything correctly. And it didn't change anything. Ha! Wonderful. That's amazing. So that's a problem. I need to modify the mesh, but I don't know how to do that yet. So let's just go back to the drawing board. The question is whether there are no changes because I'm computing the wrong values, or whether it is caused by the fact that I am not changing the mesh. This might take a little So it does change. You can see the difference between the values, even though I'm not really using helper vector. Yeah, okay, so I have disproved the hypothesis that I am not doing any computations whatsoever. I am actually doing them, but the fact might be that I'm not really changing anything in the mesh. I mean, look, this just seems like the only thing that actually gets called every time is this update box and normals. I just want the mesh to actually show some changes, whatever they are. No changes. Okay, it appears that the changes are there, but still no update. This is the spherified bunny. So it's correct. This is the correct implementation. The only thing that I'm probably missing is some kind of update function. What exactly that is, I have no idea. This is okay, so this says that this is the standard method that you should call after changing coordinates. Update box and normals. Well, why doesn't it update the mesh? This is probably not necessary. I'm doing everything correctly. So this recomputes normals. So I shouldn't have used any normal, or maybe it was necessary for me to use normals, but yeah.
1 hour later.
Okay, I am officially giving up. I have tried, well, pretty much everything that was in my power. The changes aren't applied unless you go here and you apply a transformation, and all you really need to do is just preview this and the changes will be visible. So I am currently stopping the timer finally. Alright, so it seems that the tests are over. I guess the first round of tests for finding the actual location of the functionality are pretty successful. The feature tests, on the other hand, I have encountered some issues during the almost 3 hours of looking for the solution. I have been able to successfully implement the functionality, but I wasn't able to apply the changes to the mesh so that it actually renders or sends a render request for the mesh. You know, I kind of want to know how to do this. It's pretty useful, and I want to know what I'm missing in this case. So yeah, there's that.
The next day.
All right, so a brief update on what I was doing yesterday. With the new filter, I actually found out after maybe half an hour of searching that I was missing one essential piece of information for the filter, and that was filter arity. Now, when I first saw the function that returned the parameter called filter arity, I was like, what on earth is arity? I didn't understand it. I thought it was Italian, honestly. But then I sort of accidentally clicked on the definition of the enum, and I was like, yeah, this is either going on no mesh at all, or single mesh, or multiple meshes. So arity refers to the multiplicity of the filter, on how many actual target meshes this filter is applied. And quite frankly, if you don't set that correctly, based on how the C++ switch statement works, or switch statements in general work, it will automatically go to no arity, which means that there is no target mesh. So that's why the target mesh is changed but isn't actually seen. The change isn't actually seen in such fashion. And I wasn't able to grasp it at first, but it actually worked. So the arity has to be set. Let's give ourselves a little evaluation of what we found out. First of all, the breakpoint test for the Laplacian Smooth took around 12 minutes. The second breakpoint test for Loop Subdivision was almost 7 minutes, and then the last one took only like 6 minutes. Feature test for spherified deform filter took almost 3 hours, plus the almost half an hour of fixing the filter arity the next day. And the overall evaluation for the DevOps and the testing of MeshLab Codebase looks as follows. So that was like 3 days of devoted time with approximately 4 hours of the actual testing. Now, some suggestions for the DevOps side. The system Eigen parameter shouldn't be allowed or enabled by default. The paths for the plugin binaries should be reevaluated. Also, in terms of the overall evaluation, MeshLab has a pretty learnable modular design for the filters. However, since we've had lots of issues with some of the missing parameters or like really branched out switch statements for different enums, filter design does not really respect the open-close principle. So if you want to add another feature, you need to add the behavior for the new feature pretty much into every interface function of the filter. So that's kind of violating the open-close principle. In terms of adherence to other coding standards, it is mostly adherent, not always const correct, but I mean, you get what you get. But overall, I can say that it's a well-written, well-documented, and very well-readable code. I didn't have much trouble reading it compared to other code bases. Also, we have to mention that the half-edge mesh representation is very fast and versatile. Obviously, we are pattern recognition machines. The fact that I could do this in 3 days is entirely subjective, being both my benefit and also my handicap. It stems entirely from one's experience and preferences. If I were testing a fintech app, I'd likely be as lost as I could possibly get. This is also a shout out to the Visual Computing Lab team for the years of tremendous work devoted to all the numerous features of MeshLab. I have to say that as a user, it truly is a one-of-a-kind tool to use in my field. And I'll be excited to do more work with it in the future as well. Thank you for watching, and if you'd like to see more of this type of content, feel free to comment, and if you think this video was a little bit too long, feel free to comment as well. But don't forget to subscribe and smash the like button. Otherwise, just enjoy your day, and thank you for watching again.